This is AP Precalculus review for the AP test. We are doing the three-peat activities. We are on activity M. In number one, we're supposed to match this equation with some graphs. The first thing that I'm seeing is that these x plus 1s and x plus 1s cancel out, where if I cancel out one version on the top and one version on the bottom, I'm left with an answer on the top. This is mixing a whole with a zero, or a whole with an x-intercept. Why is it doing that? Whenever we cross off factors in both the numerator and the denominator, we are creating what's known as a whole, or it's like kind of these features right here, right? Those are called wholes. But when we mix wholes with other things, weird things happen. So just as a reminder, if I mix together a whole and an x-intercept, we call x-intercept zeros. If I mix together these things, the result is a whole at that zero. So it's kind of like if I went through the x-intercept and then I quickly have a whole there, it's kind of mixing together a whole and x-intercept. Technically, it's called a whole, though. If you mix together a whole with a vertical asymptote, I'm just going to write VA, you get just a vertical asymptote. The winner is the vertical asymptote. So if I had a vertical asymptote like this and like this, notice that it technically has a whole because there is no height at that point. Just like there is no height at this point, there is no corresponding y-coordinate, there is no corresponding y-coordinate, which is why the vertical asymptote wins. All right, so I'm looking for a zero and a whole, but basically a whole when I'm at -1. Because again, when you set x plus 1 equal to 0, you're supposed to set each of these equal to 0, and you solve by subtracting 1 on both sides, you get x is equal to -1. So at the x-coordinate -1, I should have a whole that is at kind of like an x-intercept. So at -1, I have a whole and a 0, good. At -1, okay, nothing is happening, C is not right. With B, okay, I have a whole that is also a 0, okay, that's in the running. And at -1, okay, nothing is happening there, so D is incorrect. Okay, so it's between A and B. Well, the next thing that I have happening is a vertical asymptote and a whole combined, because again, I'm crossing off three versions on the top, 1, 2, 3, and then 3 versions on the bottom, leaving behind one version of these x minus 2 linear factors. Notice that the bottom here, 1, meaning that we have a vertical asymptote. When we combine a whole, because we cross things off, and a vertical asymptote, because the bottom is 0, the winner is a vertical asymptote. I should have some sort of vertical asymptote at x is equal to +2. At +2, I have a vertical asymptote. At +2, I have a vertical asymptote, and that was not helpful. All right, the next and kind of last tool in our toolbox is knowing if we are on the top part of the graph or on the bottom part of the graph. That's known as a sign chart, right? So a sign chart basically says, hey, we know that we are going to go through a hole here at -1, and we have this point that is a vertical asymptote at +2, but am I positive or negative on this interval? And I'm noticing that in between -1 and 2, I'm positive here. In between -1 and 2, I'm negative here. So in between -1 and 2, I just need to test, am I positive or am I negative? And that will give me the right answer. So I'm just going to plug in a test point. I particularly chose this interval because there's an easy test point, which is 0. If I plug in 0, I can see if I'm positive or negative, because if I'm 0, year 0, year 0, year 0, year 0, this is to the power of 2. Whenever I have an even power, I can ignore that, so it's always going to be a positive. I'll put a little positive up above there. And same thing down here. I have an even power, which means you, my friend, are also a positive number. 2, if you didn't know, is also a positive number. So when I do 0, 0 minus 2 is a negative. A negative to an odd power is a negative. And down here, when I plug in a 0, 0 plus 1 is positive, which is a positive. I have the signs on all of these. On the top, I have a negative. On the bottom, I have a positive. So let me write that again. I have a negative on the top. I have a positive on the bottom. This is my entire fraction. And a negative divided by a positive is a negative, which means in between -1 and 0, I should be negative, which means the correct answer is B. You'll see that in between -1 and 2 over here, I was positive, meaning that A was incorrect. All right, a lot of work there. Let's do number 2. Number 2, we're asked to talk about the behavior of this graph. Well, let's ignore the negative for a sec and ignore the +3. What if I just talk about y is equal to the natural log of x? The natural log of x is going to be a function that you need to have memorized in terms of its general shape. Generally, it looks like this. It has nothing over here. It's a dead man's or no man's lands on the left-hand side of our graph. And on the right-hand side, if I go through this point, which is known as 1, if I go through 1, everything to the right of 1 is positive, and up here, everything to the left of 1 is negative, and it gets closer and closer and closer and closer and closer to this y-axis. So there's the general shape. So when I add 3, that's going to shift everything left 3, which doesn't change any of these answers. And the fact that I'm multiplying by a negative, the size of this number doesn't really matter. But if I multiply by a negative, it's going to flip this and reflect this over the x-axis. How do I know it flips over the x-axis as opposed to the y-axis? That's the question, right? Well, everything everything on the outside affects the vertical direction. Everything on the inside affects the horizontal direction. If I'm affecting the vertical direction, and a negative multiplied by negative is always a reflection. If I'm moving the vertical direction up and down, that is reflecting over this direction, over the x-axis. So let me go ahead and sketch a graph that is reflected. Ta-da! All right, so this is the graph that we're really talking about. I'm going to ignore the the horizontal translation 3 units to the left. Notice that this function is constantly going down. It always has a negative slope. So it is always decreasing, not increasing. It's not A or B, it's decreasing. And notice that this is always looking like a smiley face. A smiley face means that we are concave up. Concave up is the right answer. The correct answer is C. That was kind of a bad circle. C, there we go. And then finally we have number 3. And number 3, I'm noticing the form of this one. This one is interesting because I have a mixture of a sine and a cosine with an addition and a cosine and a sine. This deeply reminds me of one of the formulas that I was supposed to memorize for a sum or a difference of trig functions. So I'm pretty sure that this one is the sine of A plus B. Here's why I know this. Sine is when I mix together my sine and my cosine. If I had double cosine at the very beginning, it would have been a cosine function. Because I have a plus sign here, sine, the S stands for same, meaning I have the same sign here. It's a plus and not a minus. So I know that I'm going to be adding these two angles together. So I know that my answer is going to be the sine of my first one, which in this case is just A, plus the other angle, the second angle here is pi over 7. Pi over 7, and therefore the correct answer here is C, A plus pi over 7. Just in case you're watching this video and you really did not know at all how to do this problem, I highly recommend you go study your flashcards. If you don't have flashcards, I have made some for you. If you come over here to Bluekit, I have a link in the video description. This is topic 3.12. You can just grind away on all of these definitions. This definition that we are using came from this one right here, question number 12, which of the following is equivalent to sine of A cosine B plus cosine A plus sine or times sine of B, and that was the one that I utilized for this knowledge. So if you need that, go ahead and use it. That does conclude our video for 3-Pete M for the AP Calculus or AP Precalculus review. Thanks for watching.